Good morning to all of you. Welcome you guys. Welcome you all. Very good morning to everybody. So how you are doing everybody? कैसे हो सभी लोग? I think we are live. Yeah, first of all, do like the session, share to all your friends. Do like the session and share to all your friends. And confirm this audio video is clear to everybody. Confirm this audio video is clear to everybody. चलो चलिए आज का सेशन हम शुरू करेगा. सबसे पहले तो आई विश यू वेरी हैप्पी क्रिसमस टू ऑल ऑफ यू. आई विश हैप्पी क्रिसमस टू एवरीबॉडी. So on this great auspicious day, so I am bringing the great news from Unacademy team, that is Secret Santa. एक मिनट. The Secret Santa, which is live now, so there is a chance to get an academy subscription just 4,999 only. An academy subscription just 4,000. We'll start. So then we'll finish this thing. Thereafter, we'll start the next one. And flash sale, which the offer will end tonight. So then try to utilize this opportunity before going to expire. And additionally, इसके साथ you will get the 3 months additional benefit भी आपको मिलेगा. 3 months का additional benefit भी आपको मिलेगा. Right. So चलिए. To avail this opportunity, you can use a code of BVREDDY. To get this offer. Unacademy test series. You can see now here Unacademy test series, which is today, which is at 11 a.m. as well as 5 p.m. 2 sessions are there, and try to utilize this opportunity. There is a chance to get 90% of scholarship आपको मिलेगा. For this is the one great opportunity for the student who are preparing for 2027 and 2028 के लिए. And these are the ESC 2025 ranks from Unacademy. Yes, so many ranks you can have a look at now. And test series which is live, so you can able to access the test series from the December 15th onwards. It was curated by the top educators of Unacademy. And recently, so we starting from 27th onwards, we are starting the new batches for GATE and ESC 2028 as well as 2027 के लिए हमने नया बैच शुरू होने वाला. And to enroll for it, you can use the code of BVREDDY. To avail these great opportunities. And so we started a new batch for this West Bengal Electricity Department. 19th December onward, the new batch has been started. And this crash course is live. So these are the courses. These many batches are running. You can find. And another great feature is Unacademy Una. With this Unacademy Una, you can directly interact with this AI tool. With this, it has 3 different modes of operations. You can see now voice mode, quiz mode, smart summaries. And according to your requirement, you can able to directly connect with this Una app. and test series which is live. You can see now here already test series is running. Test series will play a very important role for the aspirants of 2026 and the student who has completed the subject after completion of each subject. So try to attempt the test series ताकि आपको पता चलेगा how much is the level of your preparations. ठीक है. And so we do offer the 2 subscriptions. Now one is a plus वाला, the other one is iconic. प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस, लाइव डाउट सॉल्विंग, evaluator test series and courses, structured courses and PDF, live quiz and unlimited access. You can access the classes any number of time, there is no restriction. And iconic में क्या मिलेगा? All the plus features के साथ you will get additionally 1-to-1 personal coach मिलेगा and physical notes भी आपको मिलेगा. Right. And you can, according to your time convenience, you can book a time slot, then connect with your mentor and try to practice with Unacademy to achieve your dream goals. And these are the GATE 2025 rankers from Unacademy. Chalo. Let's start our discussions now. Yeah. Combinational logic circuit. In case of combinational logic circuit, what we can observe in this case? In case of combinational circuits, what we need to observe here, the present input, present output depends upon only on the present input में depend करेगा. The output, present output depends only on the present input only. It does not depends upon the past values में depend नहीं करेगा. It will depends only on the present values में depend करेगा. Right. And in case of combination circuits, and there is no feedback and clocks are not required. There is no memory required in these cases. Okay. The moment we give the input, तुरंत आपको output मिलेगा. Now, so in this topic, what we are going to discuss in a combination में, so हम discuss करने वाला off adder, off subtractor, full adder, full subtractor, and parallel adder, carry lookhead adder, multiplier, the comparators, and then multiplexer, demux, decoder, encoder, priority encoder and code converters. ये सारा कहानी हम डिस्कस करने वाला इसमें. ठीक है. चलो, first we'll start with the adders. Now let us talk about this off adder. And off adder is for the addition of the 2 single bit numbers. केवल for single bit के लिए off adder हम use करेगा. So it has a 2 inputs and 2 outputs. A and B are the 2 inputs, and so we have the outputs as sum and carry are the output. Sum and carry is the output. So the input combination will be taken as what will be now 0 and 0, 0 and 1, 1, 0 and 1, 1. These are the input combinations we have taken, and correspondingly we'll get the output. Tell me now what will get this output now? 0 plus 0. Then sum is what? Tell me 0. No carry. 0 plus 1. Sum is 1 and carry 0. No carry. 1 plus 0. Sum is 1. No carry. 1 plus 1. That is what? Tell me sum is 0. Carry is 1. Okay. Right. Now you can see the expressions now. You can tell me the expression for sum and carry. Yes, sum. What I got the sum, you tell me. Sum का min terms you tell me. Min terms of sum is what I know 1, 2. 1, 2 min terms. So 1, 2 is nothing but XOR gate only na. So which we can say it as what I know A XOR B. Yes, this XOR means what we can write now here sum which is equal to A bar B plus A B bar. This is the sum. And next, what about this carry? You tell me now. Carry ka min terms you tell me, which is equal to 3. So min term 3 means what we can write now here AB. So 1, 2. So this is what is this value? Tell me now. So 0, 1. What is the 0, 1 means how much? 0, 1 means what? 1. 0, 1 means what? So here decimal number. So convert this 0, 1 into decimal form. So what will come? 1 will come now. That's why. That is 1. And 1, 0 means what? Tell me this number which is equal to 2 na in decimal system. So that's why this 1, 0 will write it as a 2 will write. Now this is a sum and carry expressions. Now let's see this logic circuit now. And logic circuit. So we got this sum expression. Sum is equal to what we have seen. Tell me. That is A XOR B. And carry which is equal to what? Tell me now. A into B. Now let's try to implement this logic circuit now. I am taking the A and B are the two inputs we have taken. And now I am taking the XOR gate I have taken. XOR gate. So this is A and this is B. So इधर हमको क्या मिलेगा? Sum मिलेगा ना? Which will come to be a what? Tell me now. A XOR B. Next. So I will take these connections now here. And I have taken one AND gate I have taken here. So this is a AND gate. So here हमको क्या मिलेगा? Carry मिलेगा. Carry equal to what? Tell me now. AB. And this is the logic circuit. Got it? Next, of subtractor. Of subtractors, the subtractor का काम क्या है? So to subtract the two single bit numbers. For this we have a two inputs and two outputs. Inputs are A and B are the two inputs and the difference and borrow is the output. Now let's talk about the combination of inputs now. We have taken 0, 0, 0, 1, 1, 0, 1, 1. Yeah, you can tell me now outputs what will get now 0 minus 0. So the difference is 0. So, and there is no borrow. Yes, 0 minus 1. So the difference is what? Tell me now here. When you want to subtract this as 0 and 1, what we need to do here? So हमने कुछ borrow लेना पड़ेगा. We should take some borrow. We should take now here. The borrow क्या मिलेगा? 2 मिलेगा. Base will come it as a borrow. So that means what we can say 2 minus 1. 2 minus 1 किया तो क्या आएगा? So will come it as 1. Borrow ले लिया ना. So that's why borrow is active. and 1 minus 0. So that is what, tell me now, difference is 1, there is no borrow. 1 minus 1, so the difference is 0, borrow is 0. Isn't it, tell me? Now you can tell me the difference and borrow expressions we'll see now here. So tell me now difference and the difference expression. So what we have, what are the minterms of difference, you tell me? Difference ka minterms is what will be now here. So 1 comma 2. So 1 comma 2 same as earlier we have na minterms. So that means 1 comma 2 is nothing but what will be now XOR gate only na. And the next one is what will be now borrow. And borrow ka minterms you tell me. So that is 1 is a minterm. So that is 1, how we can write? A bar B. Okay. Next, logic circuit. Here we have seen the difference. We have seen 1 comma 2 minterms means XOR gate. 1 comma 2, when 1 comma 2, that is what tell me now minterms. 1 comma 2 means what? So that is A bar A XOR B equal to what tell me now A bar B plus A B bar na. So that's it. This is nothing but XOR gate. Next, logic circuit. Now you can see the difference is what the expression we got. You tell me now here A XOR B. And then borrow. So how much we got this borrow, you tell me? And borrow expression which we have it as what tell me now A bar B. Tell me how we can implement. How we can implement. How we can implement now here, same as earlier we have taken. And we have taken one XOR gate we have taken for the to get the difference. And here this is A and this is B. So here we'll get the difference will come now. That is what tell me now A XOR B. And we need the borrow. So that's why we have taken this A. And borrow के लिए what we require now A bar. So इसीलिए we have taken one, not yet have taken. And this B. If these things are connected like this. Now this here will get the borrow. That is what element of A bar B. No, yaar, borrow is A bar B. Carry is AB. Borrow is what element of A bar B. Right. In this manner, we can implement the half adder, half subtractor. Next, now let's try to implement the single circuit should behave like a adder as well as subtractor. Borrow means what? Tell me here this minterms. What are the minterms here? This one na. So this A value 0 means what? A bar. 0 means A bar, B is 1. Now how we can write? So here 0, 1. How we can write? This is A bar. This B means 1. So this is a bar or not? This is the min term. Next. Of adder. Of adder, of subtractor. So we need to work it as what tell me single circuit should behave like a adder as well as subtractor also. Now you can see now here in this case. So here of adder के लिए of subtractor के लिए difference and borrow sum is same. Only the thing is carry and borrow is different. Now we'll focus on that one. So that means I have taken this is A and this is B. I have taken A input. Here we have B. Now, so what I am doing now here, first we'll implement the sum. Sum के लिए what we require, you tell me now here. So A and B I have taken and these two are connected to one XOR gate. These two are connected to XOR gate. So here we'll get it as what tell me now here, either sum will come or it may be difference. Both will come. Both are same. Next. Now in case of a carry we need A into B and the subtractor we need borrow. That means A bar B. For this what I will do here, I have taken one XOR gate I have taken here. I have taken one XOR gate we have taken. That XOR gate we have connected. XOR gate we have connected. Now here we have taken one additional pin or extra pin we have taken now. Yes. And so thereafter we have connected these things. The gate we have taken. And the gate we have connected. Now here we'll get it as carry milega as well as borrow भी मिलेगा. Check करो how it is now here. Now you see this thing here. If S is equal to 0, what will happen now here? Here will come it as A will come. A and this is B. Then what happens now? हमको क्या मिलेगा? Output of this AND gate will come it as AB will come. AB means this is nothing but what element of carry. So from this we can say this will behaving like an off adder. Now if S is equal to 1, then see what happens now. If S is equal to 1, XOR gate, this will become A bar B na. A bar B. A bar B, this is what tell me now? Borrow. A bar B borrow. From this we can say this as a, this is off adder and this we can say this as a off subtractor. Okay. Understood. Now the single circuit will behave like a both adder as well as subtractor also. Done. Now chalo, let's talk about the full adder. Full adder. So here to add the 3 bits, for the addition of 3 bits we use full adder. So now it has a 3 inputs are there, A, B, C, 3 inputs and 2 outputs. One is sum and carry. And let's talk about this working now here. So 0 input combinations we have taken 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now tell me now here in this case, and what's the sum? You tell me now. If we add this thing, sum 0 na, and carry also 0. Sum 1, carry 0. Sum 1, carry 0. Sum, when you add now 0 plus 1, 1. 1 plus 1, so that is sum 0, carry 1. And this is, and so will come the sum is 1, there is no carry. Sum 0, carry 1. Sum 0, carry 1. Sum 1, carry 1. Okay. Now in this case, now let's talk about these connections now here. Now tell me the sum ka min terms, you tell me. And what are the min terms of sum you can see? Min terms of sum we have, that is 1, 2, 4, 7. 1, 2, 4, 7 तो हमको पता है ना. So this is a famous number. Ask you to remember this thing 1, 2, 4, 7. That is nothing but what? Tell me now. That is nothing but 3 input XOR gate. So that is A XOR B XOR C. Next carry. Carry. So what are the min terms of carry you can see? That is 3, 5, 6, 7. These two are very famous number. Try to remember. And carry. So these expressions you can see now here, which is equal to, we know this thing now, that is AB plus BC plus AC. Remember this thing. This is the majority gate. Also we have named. This is, we have different names. You can see now 3. So this term here, which is called it as a majority gate. Majority logic gate. And this is also called as self-dual expression. Self-dual expression. And this is also called as a carry of ladder. And try to remember these terms. And so we got this expression now here. Now let's see this thing here, how we can modify this thing. Now, so the carry expression, we got the relation of carry, which we have, what tell me now here? Those are 3, 5, 6, 7. And can you tell me now how we can write this carry? So 3, how we can write now here? A bar BC plus 5. A B bar C 6. A B C bar 7. A B C. So now let's try to simplify this thing. So what I can do here in this case. Now self-dual means, yesterday we have seen yesterday we have discussed about the self-dual. Self-dual means what? Tell me now. The first class we have discussed this thing. This is the 4th class now. First class Boolean algebra we have seen the self-dual. Okay, do watch the first class, then you will get to know. Shushan, so I think so. You watch the first class, then you will get to know all this explanation now. Okay. So we already all these things we have explained in previous classes. This is the 4th class, and do watch the remaining 1, 2, 3 classes. You will get to know more clarity. Now let's try to simplify this thing. What I can do here, I'm combining these two. If I combine these two here, then what I'll get to tell me now? Will come it as AB will come. And if I combine these two here, tell me, इसमें what I can take common now here? C have taken common. Then it is A bar B plus what, tell me now? A B bar. C have taken as common. Then it will becomes what, tell me now here? A B plus, this is nothing but XOR gate now. A XOR B into C. This is the second form of carry, do remember. This is another form of carry. So carry expression we have seen it as AB, BC, AC. In addition to that, this is the another form of carry. Now, got it? And try to remember these two carries. Now let's see this thing, how we can implement this full adder by using two off adders. Let's see this thing here. So I have taken one off adder we have taken. I have taken one off adder. This is one off adder. It has two inputs. Two inputs are A and B are the two inputs, and it has two outputs. So here we'll get it as what element of sum will come. Here will come it as what element of carry will come. Here we'll get the carry will come. Now you can see now here in this case, this is an off adder. Now sum means here what will come here? This is A XOR B will come now. Here what will come here? A into B will come. Right. Now I am taking the one more off adder I have taken. This is another off adder. Now you tell me now here in this case. So here this input, it has also has two inputs now and two outputs. Right. Now if I call this is input is something P, this is C. Here we'll get the sum will come. Sum means what, tell me now here? P XOR C will come here. Here what will come here? P into C will come here. Now what I am doing is I am connecting these two. I am connecting here. That means P is equal to what, tell me? A XOR B. So then it will come to be what, tell me? This is A XOR B XOR with C now, tell me. Yes, that is the sum expression we can say. Next, here what I did now here. So here we'll get this AB will come. Okay. Next, can you tell me now here? This is what will come? P means what? A XOR B. That is A XOR B into C will come here. Okay. Now these two I have taken now here. These two I have connected to one OR gate I have connected. Right. Now here will come it as what, tell me now here? Final carry milega, you can check it. So that is what we'll get here. This is AB plus A XOR B into C. Okay. Got it? This is the way we can implement the full adder by using two off adders. Done? Now let's see this thing here. Of subtractor. Of subtractor, here we are doing A. From A I am subtracting a B and C I am subtracting. Sushant, we explained this thing in the previous classes here. Previous class. Okay, this is the crash course, so here we cannot repeat the things again. So previous class we explained. This is the fourth class, and do watch the first class. You will get to know these things. Right. Now in this case, you tell me now here A, B, C. Now the input combination we have taken as 0, 0, 0, 0, 0, 1, and 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right, now you can tell me now output combinations here. So if we subtract now, anyway here to 0 banega or there is no borrow. So 0 minus 0, 0, 0 minus 1. So that is, we should require borrow required and difference is 1. Next, 0 minus 1, we have required borrow required. 1 minus 0, that is 1. 0 minus 1, borrow required. 1 minus 1, 0. 1 minus 0, 1. So this is, difference is 1, there is no borrow. 1 minus 0. So we required the 1. 1 minus 1, again this is 0. 0, no borrow. 1 minus 1, 0. 0 minus 0, 0. Next, 1 minus 1, so 0. 0 minus 1, borrow required 1. Understood all of you? Now you tell me the difference expression and borrow expression. Difference, min terms of the difference you tell me. That is 1, 2, 4, 7. 1, 2, 4, 7 is nothing but what? Tell me now, 3 input XOR gate. This can be given as what? Tell me now here, A XOR B XOR C. And then borrow. Borrow, that is given as what will get, you tell me now here. Min terms are what you can see. 1, 2, 3 and 7. So 1, 2, 3, 7. So this is the expression. We'll try analyze this expression. Okay. Done. Now let's see this thing here. The borrow will analyze now here. Borrow. So the min terms of this borrow, which is equal to what? Tell me now here. 1, 2, 3, comma 7. 1, 2, 3, comma 7. Let us try to simplify this borrow. So we'll get the, here also we'll get two forms will get. Listen carefully. So 1 means how we can write A bar, B bar, C. 2 means that is A bar, B, C bar. 3 means A bar, B, C. 7 means A, B, C. So let's try to combine them. Now here I'm combining these two here. When I combine these two here, हमको क्या मिलेगा? One second, not these things. So I'm combining these two. I'm combining. So that means what will come here if I combine? This is we required A bar B required A bar B. Yes. Now if we combine here, what will come here? A bar B will come. Next, if we combine these two here in this, I will take what will take common C common. Then it is what, tell me now, A bar B bar plus AB and into C. So you tell me what will come here? A bar B plus this is what, tell me, A 𝐂𝐤𝐴 B. 𝐂𝐤𝐴 gate now this is 𝐂𝐤𝐴 B into C. So this which we can write it as, tell me now here we can say A bar B plus 𝐂𝐤𝐴 is given as complement of XOR gate A XOR B bar into C. So this is borrow. Okay. Now we'll see the another form of borrow. So for this we'll develop the K-map. K-map. I'm taking this is A, B, C. So this is A bar and this is A. So this is B bar, C bar, B bar, C, B, C, B, C bar. So it will come to be this value. This they given these numbers 1. So this is 1, 2, 3 and this is 7. Let's try to group them. If I am grouping this thing here, I can group these two. By grouping this thing here, हमको क्या मिलेगा? You see this thing. By grouping this thing, what will get you? See this thing here. This is A bar C मिलेगा and we'll group these two. When I group it now here, क्या मिलेगा? That is BC मिलेगा. And what else I will do here? I'll group these two. By grouping this thing, हमको क्या मिलेगा? You see this thing here. This is A bar B मिलेगा. So finally, you can tell me the carry expression. Sorry, borrow expression. So this is borrow expression. What will come here? You can see now this is A bar B plus BC plus A bar C. Okay, this is a borrow. Now let's try to implement this one, this offs, by using two off subtractor. How we can implement the full subtractor? So let's see this thing, how we can implement. I have taken one off subtractor and this is another off subtractor. Two off subtractor I am taking. So this is one off subtractor. This is another off subtractor. It has two inputs and two outputs. Two inputs and two outputs. Two inputs and two outputs. Now, if I call these inputs are A and B, here will come it as what element of difference will come, and here will come it as borrow will come. And what is the difference? You can see the difference means what? Here will come it as A XOR B will come. Here will come it as borrow means A bar B will come. And if I given this as the P I given and this I given C. So here difference will come now. So the difference, what the difference will come, you see in this case here. So here will come it as what element of P XOR with C, and here is a borrow. So this borrow will come to be a what, tell me? So that is P bar into C. Now what I am doing is I am making this connection. I am connected this. If I connect these two, that means P is equal to A XOR B now. P equal to A XOR B. So then it will becomes what you see when you simplify this thing here. P means what, tell me? A XOR B XOR with C. And this is P bar. P bar equal to, that is what element of A XOR B whole bar into C. Now here, and these two borrows I am connecting via one OR gate. Right, so that means here will come it as what element of A bar B plus A XOR B bar into C. This is the borrow, final borrow. Got it? In this manner, we can implement the 2 by using 2 of subtractor. We can implement the full subtract. And so you may see this thing here. Previously, we have seen. So subtractor means order is important. Okay. So we should do always A minus B minus C we have considered. If it is other than this, then what will happen we'll see. In this case, we have seen the difference we have seen now. And what the difference expression if you do it now here, that is A XOR B XOR C. And what about this borrow expression? That is borrow expression is what, tell me, we have seen. So that means borrow expression, how we can remember, simply like a what we can say, same as like earlier you remembered na carry, same manner we can remember. Oh, tell me now what is the carry expression we have remembered? That is what, tell me now, AB plus BC plus AC we have seen now. Now this borrow means what, tell me now, we are subtracting B and C from where? I'm subtracting from AC, I'm subtracting now. So that's why put a bar on A. That's it. Okay, simply put a bar on A. Understood this thing, tell me? And it's a first form. Another form of borrow is also there now. That is what, tell me? A bar B plus. So this is A XOR B whole bar into C, the second form of bar. AB, first AB, then C. Next, let us say they ask him to do this analysis. B minus C minus A. Now you tell me in this case what I will get. And the difference expression, no change. A XR, B XR, C only, always. And what about this borrow, you tell me? So here first we'll write the carry, that is AB plus BC plus AC. Here we are subtracting from where you tell me now B से we are subtracting now. So that's why B पर bar place करो. Place the bar on B. Next, so this expression, what we can say now here? So this is B bar into C plus what tell me now here? B XR C का whole bar into A. Next, now tell me now if I want to do the C minus A minus B, then tell me. So the difference expression is same only, no change. Difference is what tell me now here? A XR B XR C. And what about this borrow, you tell me? Borrow, which is equal to what, tell me? So that is C bar into A plus C XR A whole bar into B. And the other form of borrow is what, tell me now here? AB plus BC plus AC. Where I need to place a bar? C पर bar place करना. Done. Yeah, you can see the summary of all these adders. Yes, now look at now here. Off adder. What is the logic expression for off adder? You tell me now here. That is A XR B. And carry is what, tell me now? AB. Minimum number of NAND gates required. That is 5. NOR gates is also 5 only. Now off subtractor, you tell me now. That is A XR B. And this is A bar B, borrow. NAND gates are how many? 5. NOR gates is also 5. And full adder के लिए tell me. That is A XR B XR C. Right. And logic expression for carry, which is equal to AB plus BC plus AC. NAND gates are 9, NOR gates also 9. Here difference expression same, A XR B XR C. And borrow, that is AB plus BC plus AC na. So we are subtracting from A, so that's why I put a bar on A. NAND gates are how many required? 9. NOR gates is also 9 only. This summary is very important. This summary is directly problem will come. They will ask the direct question, you can find the minimum number of NAND gates required for the implementation of full adder or full subtractor, they may ask. Try to remember this summary. Then, so the PDF notes also available, and so you can get this notes in the description link में आपको notes भी मिलेगा. Okay, and the short notes also I will share it. Short notes and complete notes, full notes also you will get. And I will show you the short notes also, how the short notes and all. Next, chalo, let's talk about next one. The ripple carry adder or parallel adder. Now let's see this thing here. Ripple carry adder. Now see this thing here. So tell me now here, they have given the two numbers A and B. So then I need to add this thing. For this addition, so see the requirement you tell me now. I want to add these two. For this, we require what we required. You can see now here. Half adder is required, or full adder is chahiye. How many bits are there? 2 bits. So that means half adder is sufficient. Half adder is sufficient. By adding this thing here, we'll get the sum will come now. And there may be some carry may come now to the next bit will be go. So we require the half adder is required. And now here how many bits are now here? So now we have 3 bits are there. 3 bits के लिए what we require, you tell me now. Half adder won't sufficient, we need full adder. So then we can call this as S1. Next, by adding this thing, we'll get some carry may come na C2. So now how many bits? These are 3 bits. 3 bits के लिए we required what, tell me now here, full adder is required. Now this will call it as what, tell me now here, S2. Now here by adding this thing we may get some carry may come na C3. So now how many bits are there? 3 bits are there. For 3 bit के लिए what we required, you tell me now. Only full adder chalega. And we'll get finally C4 may come. This is S4. And this is the final answer may come now like this. So that means here, so what is the requirement now? I have taken a 4-bit parallel adder we have taken. For the addition, how many bits, how many requirement you see this thing? We require 3 full adders and 1 half adder. So that means we'll group all these full adders and half adder to add the more number of bits के लिए. ठीक है? That we are going to see this thing. This is the full adder now. This is the parallel adder. Here what I did now here, instead of going for the half adder, I am directly going for full adder only. And by taking the C0 as a 0, the third input as a 0. Okay. We can take here, you may take it as C0 is there. And the C0 I have taken it as a 0. Then I have 3 bits now here. Those 3 bits के लिए क्या use करना पड़ेगा? Full adder use करना पड़ेगा. Right. Now this is the ripple carry adder for 4 bit. Okay. Now here these two are the inputs. These two will be added. We'll get the sum will come. Thereafter carry will come. The carry is passed to the next bit now. Next sum will come. And the carry will be passed to the next full adder. Like this the process will continue. Okay. Now let's see this thing, requirements, how we need to implement now here. For the implementation of this 4-bit parallel adder, what are the hardware requirements you tell me? So what we require, you see this thing here. If we have a 3 full adders, by using 3 full adders plus 1 half adder, we can implement or not, tell me? Next, what else I will do here? 4 full adders. We will take all full adders also we can take. Yes. And I want to implement all our half adders only. I can implement now. So that means half adder. As we know that for the implementation of 1 full adder, what we required? What we required now? 2 half adders required plus 1 OR gate required. Yes or no, tell me? Now here we have 3 full adders now. So 3 full adders के लिए what is the requirement, you tell me now here? So the 3 times of 2 off adders plus 1 OR gate. So how many required we can see now here? 6 off adders plus 3 OR gates. And along with one more OR gate off adder is there not. That means totally what I can say, 7 off adders plus 3 OR gates. All of you tell me this thing. Next. And if I want to implement all with the XOR gates, I want to implement. So one off adder, how we can implementation के लिए what we required? One off adder के लिए we required one XOR gate plus one AND gate required. Now you tell me now. Here we have 7 off adders. Means what is the requirement we can see now here? 7 XOR gates required plus 7 AND gates required plus 3 OR gates. All of you tell me this thing. Understood everybody? This is for the 4-bit के लिए. Next, now can you generalize this thing for the n-bit case? Now you tell me now for n-bit case we'll analyze it. Tell me now n-bit case, what we requirement you see this thing here. N-bit case, what will take? I will implement n full adders we can use now. Or what else I can do here? n minus 1 full adders plus 1 off adder. Isn't it? Tell me. So NAND gates are not required, don't worry. So this NAND gate then it will become it will become more complex. No need to convert into NAND gates. No, not required. They will ask this XOR gates only, they will ask mostly. Okay. Next, if I want to implement it as a XOR gates of all off adders, tell me what we can do. So one full adder means what? Tell me. One full adder means what? Tell me now. We require 2 off adders plus 1 OR gate now. Now here how many? N minus 1 full adders. N minus 1 full adders means what we can say? So that is 2 into n minus 1 off adders. Okay. Plus n minus 1 OR gates. So that means what we can say now? 2n minus 2 off adders plus n minus 1 OR gates. So here 2n minus 2, here we have 1 off adder. Together will come it as what I can say? 2n minus 1. 2n minus 1 off adders plus n minus 1 OR gates. All of you tell me. Next. For one XOR gate, that is 4 NAND gates are required. One XOR gate, 4 NAND gates are required. And then if I want to implement by using XOR gates, so that means what? Tell me now. One off adder, which is equal to what? Tell me now here. 1 XOR gate plus 1 AND gate. Here we have n minus 1 off adders, so that means what I can say? 2n minus 1, sorry, 2n minus 1 XR gates required plus 2n minus 1 AND gates required plus n minus 1 OR gates required. Done. Completed. Next one. Now let's talk about the delay analysis. Delay analysis. Here we are going to do the two cases we are going to analyze now. Sum delay greater or carry delay greater. We don't know. Let us analyze both. We'll analyze. Okay. If we talk about, let us consider the case 1. In this case, we are assuming that sum delay is more than carry delay. Let us say sum delay, we have assuming it as 32 nanoseconds. And we are assuming the carry delay which is 40 nanoseconds. Just assume. Now we'll analyze now. First of all, now all the inputs are given at t is equal to 0. A sum, so we'll get the sum will come. A sum आने के लिए कितना time लगेगा? It will take 32 nanoseconds लगेगा. Okay. And this carry C1 ये आने के लिए कितना time लगेगा? 40 nanoseconds लगेगा. Okay. Next. Now when the S1 will come, you tell me now here S1 के लिए what are the bits required? So here B required, A required, C also required. So all the bits are available when you tell me now from 14 nanoseconds onwards available. So that means what we can say S1 के लिए कितना time लगेगा? You tell me 14 plus पूरा प्रोसेस सम के लिए कितना टाइम इज 32. 14 plus 32 seconds लगेगा. Understood this point? Tell me. 14 plus 32. 14 onwards all the bits are available. Is this point clear to all of you? Tell me. Next. When the C2 will come, you tell me now here. C2 will come 14 plus 14. So this is 14 plus C1 and another 14 for C2. Okay. Now when the S2 will come, you tell me now. That is 14 plus 32. Okay. Okay. And when the C3 is available, you tell me now. That is 14 plus 14 plus 14. Now when the S4 is available, 14. No, that sum is not required for carry na. Sum is not required for carry. So that is 14 plus 14 plus 14 plus 32. Okay. And carry, so C4 is what, tell me now? 14 plus 14 plus 14 plus 14. Tell me now here, what will come? So here total sum के लिए कितना टाइम लगेगा, carry के लिए कितना टाइम लगेगा? So हम the sum के लिए overall delay, how much will come? This is 14 plus 14 plus 14 plus 32, and which is equal to 74 nanoseconds. Not visible now this part. So which is equal to 74 nanoseconds. And what are the carry, you tell me? This is 14 plus 14 plus 14 plus 14. So how much is value? 56. 56 nanoseconds. Now from this we can find the overall delay. Overall delay, which is equal to what we can say now, max of sum comma carry. Max of sum comma carry. So this will come to be a what will be now, max of sum delay, which is equal to 74 comma 56, which will come to be how much now? 74 nanoseconds. Okay. Copied now, visible to all of you. Final answer is how much? 74 nanoseconds. Next, now let's see the another case now here, case 2. In this case, we are taking the carry delay is more compared to sum delay. Let us assume. So here we are assuming in this case TPD of sum, which is equal to 14 nanoseconds, and TPD of carry will assume this as a 32 nanoseconds. Just consider. Now let's analyze now here in this case. Tell me now here. So tell me now, S नॉट के लिए कितना टाइम लगेगा, सम के लिए कितना टाइम लगेगा? सम के लिए it is 14, and carry के लिए how much time you tell me now? This is 32. Okay, C1 के लिए. Next you tell me now, S1 के लिए कितना टाइम लगेगा? This is 32 plus 14 लगेगा. All of you. C2 के लिए how much now? This is 32 plus 32. And S2 के लिए that is 32 plus 32 plus 14. Next C3, so that is 32 plus 32 plus 32. Now S3 will come it as 32 plus 32 plus 32 plus 14, and C4 32 plus 32 plus 32 plus 32. Okay. Now you tell me now sum ka delay. Yes, how much the sum delay you tell me? So this 32, 32, 32, 32. So this value 90, 96 plus 14. So this is now 110 na, 110. Next carry, which is equal to 32, 32, 32. So this is 128 na, 128. Overall delay means what I will know, max of this. Overall delay. overall delay which is equal to max of sum comma carry. So how much is value, tell me? That is 128 nanoseconds. All of you. And from this we'll generalize one statement now here. One formula will develop now. In case of n-bit parallel adder, so this delay, overall delay formula, which is equal to n minus 1 into TPD of carry, plus, that is what I'll get a max of, tell me now what will come here, sum comma carry. Max of sum delay comma carry delay. Okay. This is the generalized formula for to find the delay in case of parallel adder. N minus 1 into TPD of carry, max of sum delay comma carry delay. Right? Next, yeah, take this problem. A 16-bit ripple carry adder is realized using 16 identical full adders. If the TPD of carry given as 12, sum is given 15, they are asking to find the overall delay. Yes, finally, max only. We need to find maximum result, maximum value. Right, so overall delay formula you tell me, which is equal to n minus 1 into TPD of carry plus max of sum comma carry. So I will commit as what element of n minus 1. So 16 now. So it is 15 into TPD of carry. How much the carry delay is 12 nanoseconds plus max of, yes, some delay is how much? 15. Carry delay is 12. So how much now? 15 into 12 plus 15. So I will come 15 common, that is 12 plus 1, 13. Yeah, how much this value will come? That is 195 nanoseconds. Next. Now let's talk about this subtractor. Subtractor is a parallel subtractor. Subtraction. So subtraction means what can be done here? Basically subtraction also should be done by using adders only. How we can do here subtraction basically? So if I want to do this as a minus b, So how we can do here? Y is equal to, this is A plus of, we can treat as minus B. Minus B, how we can write, you tell me? That minus B, then how we can write? That is Y is equal to A plus of minus B means what element of 1's complement. That is given as what element of 1's complement of B. Okay. This is the way we used to do. Yeah, in this is the 1's complement subtraction. And the other way we can do 2's complement subtraction also, we can do it. Here we are doing the 1's complement subtraction here. A and B complement of B, that's why we have taken one NOT gates are taken, you can see. We have taken NOT gates are taken. So here, so it will come it as what now B3 will come now here. This is B2 bar, this is B1 bar, and this is B0 bar. So this is A0, this is A1, this is A2, this is A3. Then we'll add it. Okay, this is the way we can approach the subtraction. Fine. This is the 1's complement subtraction. Now let us see this thing. One circuit should behave like a subtractor as well as an adder. How we can achieve? We can see that one. Same circuit will behave like an adder as well as subtractor also. Here we have taken one additional pin we have taken. If this M is equal to 0, what will happen? We'll see. Now you tell me now, I have taken, if M is equal to 0, what happens? M is equal to 0. So this is 0, 0, 0, 0 connected. So you can see now here, what is this thing? 0 XOR with B will come it as B only now. Here will come it as B3. This is B2, B1 and B0. Then these are given to the full adder. Then what happens now? The circuit will behave like a parallel adder in that case. Then the circuit is what I can say, parallel adder. Okay. Now let us consider if we have taken this as M is equal to 1 we have taken. Then see what happens now. If the M is equal to 1, what happens? If this is 1, this is 1, 1, 1, 1. Then here we'll get the B bar, B2 bar, B1 bar, B3 bar. 1 XOR with B will come it as what element of B bar will come now? Complement. So that is M is equal to 1. So in this case, what will happen, you see? In this case, so it will come, so then will be added as what, tell me now here? So if you see this thing here, this is A plus of, this is what, tell me now? B bar, this is a 1's complement, that is 1's complement of B plus 1 we added. So that means this is nothing but A plus 1's complement plus 1, that is called as a 2's complement now. Then we can call this as a 2's complement of B. So this is nothing but what we can say now here, A plus 2's complement of B. This is called a subtractor now. So we can call this as a, then it will behave like a parallel subtractor. Okay. Done. Completed? Chalo. Next one, lookhead carry adder. Lookhead carry adder. So the problem of the ripple carry adder is what? The problem of the ripple carry adder is, so in this case, the carry dependency, if we observe carefully, here you can see in the formula itself, where n is a number of bits. If the number of bits increase now, what happened to delay? Delay also increases. If the number of bits increases, delay will increase. So that means what happens, tell me now, here we try to minimize the delay. For this purpose, the problem is what happening here. Here C2 has to wait until C1 has to come. C3 has to wait until C2 has to come. C4 has to wait until C3, C2, C1. If you see here, so this is C4 depending on C3, C2, C1. If we have taken 100 bits, we have taken. C100 will depends upon all previous 99 may depend karega. Isn't it? That is one of the major problem of this parallel adder. So to avoid this thing, we are developing the carry ahead adder, lookhead carry adder. So in this case, carry dependency we will nullify. How will nullify that we are going to see. And of course, this is the fastest adder among all. Obviously, the complexity also increases. The complexity increases means cost also increase. Okay. This is the fastest adder among all. Here, this is the carry lookhead adder. You can have a look at now here, this thing. This is the carry lookhead adder. So in this case, if we see here what we are going to do basically, sum expression is there now. And what is the sum expression we have? A XOR B XOR C, sum expression. And this I am calling it as SI, ith sum, which is equal to I XOR BI XOR CI. Okay, next carry. So this is what the carry expression we'll write. And what is the carry we know, which is equal to what, tell me now here, AB plus A XOR B into C. I can write this as CI plus 1, which is equal to AI BI plus AI XOR with BI into CI. Here we are writing this GI, which I am calling it as a carry generator. Carry generator, that is given as GI, which is equal to AI into BI, and PI is calling it as a carry propagator. Carry propagator. And where this PI, which is given as AI XOR with BI. Now here you can tell me now some expression SI, which is equal to AI XOR with BI XOR CI, which is equal to what, tell me now here, PI XOR with CI. And this is CI plus 1, which is equal to GI plus. So this is PI into CI. right? Okay. So the circuit which is developed here like this. So here this is the level 1. Level 1 we have the GI, PIs are implemented. In the level 2 we have this is a AND gates, you can see. Level 3 we have OR gates and level 4 we have XOR gates. लेवल 3 में अब हमको कैरी मिलेगा, कैरी मिलेगा. सो हियर यू नो नीड टू बाय हार्ट दिस थिंग, बट ये पिक्चर आपका दिमाग में होना पड़ेगा. सो हियर they will ask some question, they will ask, I will tell you what type of questions they will ask. Okay, ये पिक्चर आपको दिमाग में होना पड़ेगा. Now let's see this thing, hardware implementations. How many levels are there? You can see now. It has a 4 levels are there. In level 1, what we have, tell me. Level 1, we have the XOR gates and gates. Here, how many bits we have taken? 4 bits we have taken. 4 XOR gates and 4 AND gates. If we have taken n bits we have taken, n bits we have taken, then what happens? You tell me now. It has a n XOR gates are there plus n AND gates are there. Okay, level 1, all of you. And what is there in the level 2? You see, level 2 here we have 1 AND gate, next 2, next 3, next 4, like this will keep on, will go now. Next we can see this as first 1, next we have 2, next we have a 3, next we have a 4, like this will be keep on, will increase. So that means how many are there? N bit case. So I can say this as n into n plus 1 by 2, sum of n natural numbers now. These many AND gates are there. Okay. Next level 3, what we have? Level 3. We have the OR gates are there. How many? How many these OR gates are there? N OR gates. And level 4, we have XOR gates are there. How many? N XOR gates. All of you this thing, tell me. Done? Next. Now you tell me now how many total gates for the carry Kelly, how many? Where is the carry is available here, and here in this level what we have, tell me now here. In this level we have GI and PIs are available. So here in this level we have a carry generator, and carry propagator. Carry generator, carry propagators are available in this level. Next, in the level 3 तक हमको full carry मिलेगा. And this level 4 we have a total sum मिलेगा. Done? Next, now you tell me now total number of gates required for carry. Carry is available in the level 3 only now. Level 3 means what? So we have this thing. Level 3. Tell me now here n XOR gate, n AND gate, this much. Tell me what we have total number of gates are how many? We have this is n plus n plus n into n plus 1 by 2 plus n. These many total gates required now. So how many we can say this is 3n plus n into n plus 1 by 2. Okay. Next, total number of gates for the sum के लिए how many gates required? Sum means level 4, that means plus n. So this is n plus n plus n into n plus 1 by 2 plus n plus n. Total will come it as what? Tell me now. 4n plus n into n plus 1 by 2. Okay. Next. And we'll talk about delay analysis. Delay के लिए, so where the total is at total carry will come, total carry will come in the level 3 में मिलेगा. Level 3 delay. So this carry delay means what we can say level 1, what we have, tell me. In level 1 we have what we have here, AND gates and XOR gate. These two will be run parallelly. Whichever will take maximum delay, that has to be considered. So that means maximum of XOR comma AND gate, whichever will take maximum, that delay has to be considered. Plus level 2, what we have, AND gates and the delay. So that is TPD of AND gates. Next, level 4 we have a OR gates. So TPD of OR gates. Okay, level 3 में carry मिलेगा. अगर sum के लिए क्या है? Level 1. What is the level 1 we have? XOR gate is there. AND gate is also there. Plus level 2 we have AND gates. So delay of AND gates. Next, level 3, what we have, tell me. Level 3 we have a XOR gates. So that is TPD of OR gates. Level 4 we have XOR gates. TPD of XOR. Okay. Okay. This is a delay. Now if you observe here, the delay remains constant for any number of bits. If we increase the number of bits, what happens, you tell me. If we increase the number of bits, what happens, tell me now. How the circuit will increase now? Horizontally will increase or vertically will increase? The circuit will increase vertically. Vertically still we have same levels only now. Still we have same number of levels only, isn't it? Same levels means, so the delay remains same only. Horizontally there is no change of the circuit. It is only the vertically will change the circuit. Fine, all of you? PDF is not available. Won't you got the PDF? Yes, मैंने कल टेलीग्राम चैनल बोला ना, सो उधर ज्वाइन किया आपने टेलीग्राम पर। तो सो बी रेड्डी, सर एक बार ये चेक कर, इस पर मैसेज करो मुझे टेलीग्राम पर, टेलीग्राम। इधर इस पर मैसेज करो, मैं आपको शेयर करूंगा नोट्स। ओके, सो हियर, सो the student, those who want the notes and also do message me, so message me in the telegram, this one, so I will share the link. We'll create some WhatsApp group, we'll create some group, we'll create, and I will regularly post the updates. Okay, and do message me, इस पर मैसेज करो सभी आपने। Next, completed this one? Take this thing. The minimum number of gates required for implementation of a 4-bit lookhead carry adder. How many gates required for the implementation of a 4-bit lookhead carry adder? So here total gates we need to find. So that means total number of gates are how many? That is given as 4n plus n into n plus 1 by 2 na. Tell me how much now here. This is 4 into n. The bits given as 4 now here. 4 plus 4 into 5 by 2 will come it as 16 plus this value 2, that is 10, which will come to be a 26. Next, now see this thing here. Doing the propagation of a carry lookhead adder, if carry generator and carry propagators are already available, then the minimum number of gates required. Tell me now how many gates required here. They are saying that carry generator, carry propagator is already available. That means level 1 pura available hai. Level 1 is already available, so we should talk about the level 2 onwards. We'll talk now here. So you tell me now what we have. Level 1, level 1. So level 1 what we have, tell me now here. So earlier we used to take now here. So this means n XOR gates plus n AND gates. Those are not required. Those are already available. So level 2 में क्या है? n into n plus 1 by 2 AND gates. And level 3 में क्या है? We have n OR gates. And level 4 में क्या है? We have n XOR gates. And this is already available, so no need of this thing. So we need to implement. So here only these things only we required. Only these things only are required now for implementation. So that means how many gates required? So that means number of gates required. So how many now here? These are already available. Now tell me how many you can see now here. That is n plus n, 2n. 2n plus n into n plus 1 by 2. Okay. Understood this one? Next one, binary multiplier. Binary multiplier. So here tell me now, I want to multiply these two numbers. Tell me what we can do. First we'll multiply. This is A0 into B0. Next we have A1 into B0. Next we have A0 into B1. Next we'll multiply. Delay will constant. Delay is independent of number of bits. Then we add now. Then will come it as S0. It will come S1. By adding this thing, there may be carry may come na C2. This is S2. Maybe C3 may come. Now this is the overall delay. Now you see this thing. What are requirements you see this thing here? Now, so in this case, so here for A0, B0, we required one AND gate. So for this required one AND gate is required now here. So that means how many number of AND gates are required, you see? Number of AND gates. Number of AND gates required, which will be equal to how much now here? 1, 2, 3, 4. That is 4 is required. And this number of adders, how many adders required, you see this thing here. How many adders required? So here we need to do one addition 2. Here we need 2 adders are required. Right. Now let us say if the given the number is given like this. Now you tell me now how many AND gates and how many adders required. First we have this is A0 into B0. So this is A1 into B0, A2 into B0. So this is A0 into B1. So this is A1 into B1. Next A2 into B1. So we have this is S0, this is S1, this is S2, and this is S3. So here by adding this thing here we'll get this some carry may come now. This carry, this is C2, and this some carry may come C3. So you tell me now here how many required. That is number of AND gates. How many? Number of AND gates required. How many required you can see? 1, 2, 3, 4, 5, 6. 6 required. Next one, number of adders. How many required? How many required here? 1, 2, 3. 3 required. So here we should do addition these numbers. Now here this is one time and this is another time. So how many time additions are there? 3 times only now. So that's why 3 adders are sufficient. Done. Next, magnitude comparator. Magnitude comparators means what? Tell me now. It will compare the magnitude of a given two numbers. Here it will compare only magnitude only. It does not compare the sign. Sign won't consider. It will do only the magnitude case we use. Let's see one by one. First, let us consider the 1-bit comparator. I have taken 1-bit magnitude comparators. So this is A is 1 bit. A may be either will take 0 or maybe 1. B may be take it as 0 or 1. I need to compare these two. Let's talk about this comparison. Now here A value 0, 0, 0, 1, 1, 0, 1, 1. So obviously when you compare the two numbers, what are the possibilities you tell me now here? Maybe less than, maybe greater than, maybe equal. Okay. So when I compare this thing here, that's why we have three possible outputs are there. When I have taken A is equal to 0, B is equal to 0, what will be the possibility? Tell me here. In this case, A less than B, this is false now. A equal to B, true. A greater than B, this is also false. A less than B, yes, this is true. A equal to B, false. A is greater than B, that is also false. Here 1, 0, A less than B, that is false. A equal to B, also false. A greater than B, true. 1, 1, so this is false, this is true, this is false. All of you understood this thing? Which type of adder? If it is 2 bits means half adder, 3 bits means full adder. If you see, so that depends upon the number of bits. Here if it is a number of bits are 2, that is half adder. More than 2, then we will go for full adder. In this case, half adder will fine. In this case, half adder will work. And in this case, we have to go for full adder. And in this case 2 bits only now, that's why we can go for half adder. Right. Now you can see now here. Now in this case y1 we have taken A less than B. Tell me in this case what happened? A less than B. So in this case for the minterms you see this thing here. A less than B. This is only the minterm, right? So we'll come it as what? Tell me now. A bar into B. A equal to B. In this case two possibilities are there. That is what? Tell me. A bar, B bar. The minterms A, B. This is nothing but what? Tell me now. A 𝐿0 B. This is nothing but A 𝐿0 B. And A greater than B. In this case, what? Tell me now. A, B bar. Okay. Understood the logic expression? Now let's talk about the 2-bit comparator. 2-bit comparators, we have taken the 2 bits. Now A 2 bits, B also 2 bits. And here if we see here, in this case 2-bit magnitude comparator. So here also 3 possible outputs now. Maybe less than, maybe greater, maybe equal. Okay. So shall we develop the expressions now? Take this one. 2-bit magnitude comparators y1. So here we have taken A we have taken it as A1 A0. B is taken as what? Tell me now. B1 B0. Now you tell me in this case how we can write. A less than B means what? Tell me now here. How will compare the two bits now? First of all, you can imagine now, let us say, comparison will be done from LSB will do or MSB will do. For example, if A is equal to 27, B is equal to, let us say, 45. What I can do here? So comparison will be done from MSB se shuru karega, always do remember. If this will compare this MSBs now, if the whichever is high, that will be greater. Whichever is low, that is less, isn't it? Now what I can do here, I want to A value less than B. For this case, what is the condition we can say now here? That means if A1 is less than B1, can I say that A less than B? If A1 is less than B1, can I say that A is less than B? All of you tell me. Next. So sometimes the both MSBs may be equal, isn't it? If the MSBs are equal, that means what I can say here, if A1 equal to B1, then we'll compare, the next bit will compare. That means what I mean, A naught is less than B naught. Okay. Okay. Understood? Now, this is the logic we developed. Now we'll convert this logic into Boolean expressions. So how will convert into Boolean expression? You tell me now. A1 less than B1 means we can say this as A1 bar into B1. A1 is 0, B1 is 1. If A1 equal to B1, equality in the is what I know X naught now. A1 equal to B1. Next, what I can say now here, A naught bar B naught. Okay. Next, Y2 tell me now. A equal to B means what I can do, tell me now. So I can say this as A1 equal to B1. Along with this A naught is also equal to B naught. Then only I can say that A equal to B. Right. So that means how will convert into a Boolean expression here. This is A1 X naught B1. Next A naught X naught B naught. Next A greater than B means how we can write now here, this is A1 greater than B1 plus if A1 equal to B1, A1 equal to B1, then so that the next bit we should compare now, A naught must be greater than B naught. Equality, XNOR is called as equality gate. So in the previous second class we discussed this thing. Do watch that one, there you will get to know. XNOR gate is called as equality gate. Equivalence gate, XNOR. Now you tell me now how we can develop now. This is A1 B1 bar plus A1 equal to B1 means A1 X naught B1. Next A naught B naught bar. Okay. This is the way we have developed the expressions. Understand this thing. Now let's talk about 3-bit case. the same manner we can able to implement the 3-bit also. Yeah, you tell me now 3-bit case means A. A contains 3 bits now, A2, A1, A0. B also contains 3 bits, that is B2, B1, B0. Now you tell me now A less than B. How we can write this A less than B now? First, so this I can write the expression as A2 less than B2. Okay. From this, can I say that A is less than B? If not, if this A2 equal to B2, then we'll check it now. Next A1. Next A1 less than B1 plus if A2 equal to B2, A2 equal to B2 and A1 equal to B1 and this is A0 is less than B0. Is it fine? Now how we can write this as Boolean expression, this one tell me. So this is A2 bar B2 plus A2 X0 B2. Next A1 bar B1 plus A2 X0 B2 A1 X0 B1 and A0 bar B0. Okay. Done. Next one, A equal to B means equivalence. So means what we can say, tell me now, A2 equal to B2 into A1 equivalent to B1 into A0 equivalent to B0. And this we can write as what, tell me now, A2 X0 B2 and this is A1 X0 B1 and this A0 X0 B0. Next, A greater than B. How we can write, to tell me now, A greater than B case? So this means A2 greater than B2 plus A2 equal to B2 A1 greater than B1 plus A2 equal to B2 A1 equal to B1 A0 greater than B0. So then it will come to be a what, tell me? This is A2 B2 bar plus A2 XNOR with B2 and this is A1 B1 bar plus A2 XNOR with B2, A1 XNOR with B1, and this is A0 greater than B0. Yeah, tell me now here, this logic clear to all of you, tell me. So based upon that, we can able to develop any logic expressions for 3-bit, 4-bit, 5-bit. Anything we can compare now, we can able to develop it. Expression, tell me. Done. Now you tell me now here, how many input combinations can be possible? A0 greater than, this is A0 B0 bar. Yes, correct, only A0 B0 bar only. What I wrote? Okay, here na last thing. No? Okay, so A0 B0 bar. Yes. Now let's see this, how many input combinations are possible. The number of input combination, total number of input combinations are how many you can see? Total how many input combinations are possible? 2 power 2n input combinations are possible. So how many less than combination, how many equal combinations? So the total equal combinations are 2 power n, and so then total is 2 power 2n minus equal is 2 power n by 2, and this is 2 power 2n minus 2 power n by 2. Are the equal, are the less than? Okay. Next. Find the number of 1-bit comparators, AND gates, OR gates required to implement 2-bit comparators. I want to implement the 2-bit comparator by using 1-bit comparator. Means if they given A given as, let us say this as A1 A0, B given as, that is B1 B0. So I have to implement by using 1-bit comparator, we have to implement it. So I have taken as, this is one 1-bit comparator, this is another 1-bit comparator. Now it has the inputs, we can see now 2 inputs and we have 3 outputs are possible. So here we can say this as A1 B1. Here I am given this as A0 B0. And what will be the possible combinations will come, you can see now. The possible things are what we can say now here. So this is possibilities are less than, greater than, equal combination. So let us call this, I am calling it as L1 less than, and this I am calling it as E1 equal, and this I am calling it as G1. And here this is L0, G0, sorry, L0, E0, and this is G0, greater combination. Okay. Now you can see now here first. Yeah, tell me now here, for this A less than B, what the expression we should have? A less than B, what the expression you tell me now? When you say this as A is less than B, in this case the expression is what we can say, A1 is less than B1 plus A1 equal to B1, into A0 is less than B0, isn't it? Here where we will get this A1 less than B1? Here will come now. A1 equal to B1 here will come. So this means now, so this I will take now here, यहाँ से एक one gate. So here these two I have connected to a AND gate. These two, and then we'll get it as this is what I'll be now L1 plus this is what I'll be now E1, and this is what I'll be now here L0. Okay, L1, so this is E1 L0. So tell me now L1, so we should implement now. Here we'll get it as what I'll be now E1 and L0 we have. And we have taken one more. This OR gate I have taken here. Then OR gate is connected here. So this one. Here we can say this has what element of here Y1 if I call this is what element A less than B will come. Okay. Next, if I want the A equal to B, tell me A equal to B case, what we should be done here? A1 equal to B1 into A0 equal to B0 we should get. A1 equal to B1, that means what tell me now? This is L, so this is equal na E1 and E2. This is E1 and this is E2, E0. Where we have here E1, here we have E1. I will take the connections. These two connected to AND gate. So I have taken one AND gate I have taken here. Imagine now here this one input is connected as what E1 is connected, other input is E0 connected. Less than, greater than, yeah, less than, greater than. L means less than, E means equal, G means greater. So these connections will be done like this. Next, what else now here we should implement? A greater than B also we should implement now. Here this is Y2 is what element? A equal to B. Tell me now how we can implement A greater than B. For this A1 greater than B1 plus A1 equal to B1 into A0 greater than B0. A1 greater than B0. Okay, I have taken one AND gate here. For this one, this is whatever G1 plus that is E1 into G0. E1 into G0. So here we have E1. So this is taken one connection here. And this is G0. Here we'll get. And we have taken one OR gate we have taken. And let us say this is Y3 equal to what element of A greater than B. So G1 to be connected. So G1, okay, we have taken G1 here. Is connected like this. Okay, now in this manner we can implement. Now you see how many requirements you see this thing here. How many AND gates required? So here the comparators are 2 required. AND gates are how many required? 1, 2, 3. 3 AND gates. OR gates are 2 OR gates required. Okay. So we can write now here, this is the number of 1-bit comparators. How many? 1-bit comparators, how many? 2. And the number of AND gates. How many AND gates required? AND gates are 3. And the number of OR gates. How many OR gates required? Which is 2. Right. This is the way we can implement it. Got it? Done? Chalo. Next one, multiplexer. The next concept, multiplexer. Multiplexer, which is called as a data selector, many to one, universal logic gate, parallel to serial converter. Different names for the multiplexer. Okay. And this multiplexer, what it will do here? Same manner we'll try to implement 3-bit case. Same manner we can try to implement. So in this case, we just imagine now here. So here the data is coming from the 2 different ways is coming. Here the data is coming and here we have only one is required. So what should be done here? Now just imagine now the 2 roads are there here and there are the 2 roads are junction and we have only one road is there. And here we have one vehicle is there. So this is now A and B, the 2 persons are coming in their vehicle. Now here there is junction, only one road is there. So that means how this fellow, which fellow has to come? No, they used to give this as what, tell me now? Yeah, so 2-bit and 4-bit they used to give. And only one fellow has to come here. Which fellow has to come here? So that depends upon what, tell me now here, 2 vehicles are coming in the 2 roads, but at the junction only one road is there. Which fellow has to come? So that was decided by the traffic constable. That was decided by who will decide now here? Traffic constable will decide now. Which fellow has to come. So that is the mechanism of the multiplexer. And the traffic constable will assign this as a 0, this as 1. If traffic constable 0, if they assign the zeros, if it is showing, then output may, so this A fellow will go here. If they saying the traffic constable 1, and then who will go here? B will go here. Understood what I am saying here? So done. Got it? What I'm saying? So that's why here we have a data selector. So you see this thing, data is available in the form of A, B, C, D, so much of data. And whichever the data I need, I can able to select it. That's why this is called as a data selector. That so many inputs are available here, but only one input will come as output. That's why it is called as many to one. It is also called as universal logic gate. I will tell you why it is called universal logic gate. So this is parallel to serial. All the data is readily available, and the data will come outside now. That's why this is called as a parallel to serial converter. Okay. And the general basic structure of this mux is 2 power n cross 1. This is the general form of this multiplexer. Means if I have taken n is 1, so then we have this is 2 cross 1 this mux. N is 2, then we have a 4 cross 1. N is 3, that is 8 cross 1. 16 cross 1. And this is 32 cross 1. Like this, these are the mux available. So random size mux are not available. So if somebody asks what is the 10 cross 1 mux, this 10 cross 1 mux does not exist. Okay. So only the mux sizes are like this always. 2 cross 1, 4 cross 1, 8 cross 1, 32 cross 1. Like this type of muxes only possible. Okay. We ask some random size mux are not available. Where 2 power n is what tell me now? Number of data inputs. And the 2, so n is a number of select lines. And 1 is output. Output is always 1 only. Output is always 1 only. And this multiplexer we can indicate it as like this. And here outside we have the output. The output is always 1 only. And here we have the input lines, input data inputs. Here we have a selection lines. And here we have the data inputs, we can say. This is the data input. Here we have a select lines. Select inputs, we can say. This is the form of this mux. Okay. Now let's see that, let's understand the 2 cross 1 mux, how it is. A 2 cross 1 mux will have a 2 input lines and 1 selection line, 1 output. Here we are assuming this as input lines. This is I0 and I1. These are the inputs. And the 2 cross 1 mux, this is the selection line and Y is the output. Y is the output. Okay. Now here you see this thing, the 2 cross 1 mux, how it will function. Now here S0 is a selection line, S0, and this is Y. If we have given this S0 equal to 0, if we have given, then there is a connection will establish this I0 now here. And whatever we have given to this terminal, so that will come as output. Understood what I am saying? Agar if I given S0, this is given as 1 we have given. Now then this connection is removed. Now this connection is established. It is like switching action. Then whichever is connected to here, this I1, that will come as output. What will come the output? You can tell me now here. I1 will come as output. Okay, so that's why we can say the logic expression Y, we can say this as, this is S0 bar into I0 plus S0 into I1. Okay. This is the 2x1 mux working. Next. Now let's see the 4x1 mux. 4x1 mux. And 4x1 mux, it has a 4 inputs, 2 selection line, only 1 output. Only one fellow will come as output at a time. Now you can tell me now I have given the input combination 0, 0, 0, 1, 1, 0, 1, 1 we have given. Right? And you can imagine now here we have the input combinations you have given. Let us say this thing here, I have given this as SRK. And here we have given it as a, so this thing, and we have given another fellow, Salman I have given. And here I have given this as a big B. And here I have given it as BV REDDY. BVR I given. Now you tell me now here. So you tell me now, agar if I given it as 0, 0 we have given. You tell me now what will come the output, you tell me. Output पर क्या मिलेगा, you tell me now. That is the internal circuit. The circuit is designed like that. So if it is I0, so here this is correspondingly we have 0, 0 means what, tell me. So when you have given S is equal, S0 equal to 0, that means 0 means now this will give the only I0, whichever is connected to I0, that we should design. That only will come. Here, what will come here when I have given the 0, 0, 0, 0 when you have given. So 0, 0 means what, tell me now here, what is the decimal value of 0, 0? 0. That means whichever is connected to that 0, whichever is connected to the 0, this is I0 is 0 na, that fellow will come as output. When you have given 0, 1, 0, 1 value means 1 na. That 1 means what, tell me now, this is means which is a suffix, you see this thing I1, input I1, I means input, 1 is this number. So that means whichever is connected to this I1, that will come as output. Yeah, now you can tell me now here how this output process will take place. We have given the inputs, we have given, you see, we have given 0, 0. What will come the output, you tell me. And whichever is connected to I0, that will come as output. Yes, 0, 0, 0, 0 means what, tell me now here, I0. And which is connected to I0 now here. So this I0 will come, which is connected to I0. SRK is connected now. So that's why SRK will come as output. Understood what I am saying? I0. 0, 1. 0, 1 means what, tell me now? 1. Decimal value of 0, 1 is 1. So 1 means what, tell me? I1. Which is connected to I1 here. Salman is connected. So this is I1. So here what is connected, you tell me now here. Salman is connected. The Salman will come as output. When you have given 1, 0. 1, 0 means what, tell me now? 2 na. 2. Which is connected to 2, you tell me now. Amitabh is connected. So that means I2, that I2 will come as output. Understood what I am saying? Next one, 1 1 1 1 we given 3. So 3 4 3 which is connected now here, that is BVR is connected now, so that BVR will come as output. Isn't it? Understood what I am saying? So now tell me the logic expression, how we can write the logic expression. So this y which is equal to, so this is S1 bar, S0 bar. In that case, which will come the output now here? I0 will come. Next, S1 bar, S0. In this case, what will come here? I1 will come. Next, S1, S0 bar, I2 will come. Plus S1, S2, S1, S0, not 2. And this S0, which will come here, I3 will come. Okay. Done. Next one. See this one. Find the minterms. Find the minterms. Now you see this thing. I will find the minterms, you tell me now here. So this is f of a, b, c. Look at now here. So selection lines are given to a, b, c. When you have given, tell me now here if it is a bar, b bar, c bar. That means 0, 0, 0 na. 0, 0, 0 means which will come, you tell me now here. Whichever is connected to 0, that will come as output. That is, which is connected now, 0 connected now, 0 will come as output. All of you. Next, what will write now here? Next 1. A bar, B bar, C. That means 1. 1 for 1 which is connected, you see this thing, 1 is connected. That 1 will come as output. Understood, you tell me? Next, when you have given this as next 2, A bar, B, C bar means 2. For 2 ko what we have connected? 1 connected. Next, for 3, that is A bar, B, C. Now 3, for 3 what is connected? You see this thing here, 0 connected. Plus, and 4. Plus 4, what we can say now? A, B bar, C bar. For 4, what we have connected? 1 connected. Next 5. A, B bar, C. Into 5 ko 0 connected. Next A, B, C bar. 6. 6 ko 1 connected. Plus 7. A, B, C को 1 connected. So now you can see now here, we multiply this term is 0 na. Yes, this term is also 0. Yeah, this term is also 0. Finally, what we have, tell me now here, f of a comma b comma c. What is left out? Tell me now. A bar b bar c plus a bar b c bar plus a b bar c bar plus a b c bar plus a b c. Now we need to find the min terms now here. Min term, that is what? Tell me now here. 6 means what here? 6 means how will write 110 na? How will write the 6? 110. 110, 6 connected to 1 na. Now you tell me now, this is 0, 0, this is 1. 0, 1, 0. 1, 0, 0. 1, 1, 0. 1, 1, 1. So you can tell me now here, f of a, b, c, which is equal to this term, which is equal to how much now? Min term 0, and this is 2. So this is 1 now. This is min term 1, and this is 2, and this is 4, 6, and this is 7. So that's why these are the min terms. Okay. Done. Next. Yeah, you can see now here the output of the multiplexer circuit shown below expressed in terms of the inputs P, Q, R is. Min term is SOP. Yes. Now you tell me now how we can write these expressions now here. Here this S1, S0 is connected to PQ now. So means what we can say now, P bar, Q bar, and P bar, Q bar means 0. 0 connected to I0. I0 को क्या connected? R is connected now. So into R plus. Next P bar into Q, that is 1. I1 को what connected here? R bar connected plus. Next P Q bar, what is connected? R bar is connected. Next what? Tell me now. PQ into R. So now you can see the min terms now here. Min terms. So this is 0, 0, 1. 0, 1, 0. 1, 0, 0. 1, 1, 1. So what are the min terms? You tell me now here. 1, 2, 4, 7. Yeah, remember this 1, 2, 4, 7 is called as what? Tell me. XOR gate now. So that's why what I can say, this expression P XOR Q XOR R. This is 1, 2, 4, 7. Right. Next. And you can tell me now in this case. So if I call this is Y1. Now you tell me now this Y, first of all here this output. This output is Y given, this is given as X. Okay, so first we can tell me the Y value. Here which is equal to what? Tell me now. A bar B bar into what? Tell me now. 0. I0 is connected to 0 now, so that is 0 plus A bar B bar into I1. I1 means connected to 1 now. Next A B bar into 1. Next AB into 0. So what I will get this y value, tell me now here. So this term is 0. So we have A bar B plus what, tell me now here, A B bar. So what is this thing? This is nothing but XOR only now. So we can say this as A XOR B. This is A XOR B. Okay. Now you can tell me now, here we got, this is what, tell me now, y we got now. Now this y is applied. Now we can get this x now here. X means this one. Here the selection lines are y and c. So that is y bar c bar into 0 plus y bar c into 1 plus yc bar into 1 plus yc into 0. Okay. So this x is equal to, so this is 0 plus y bar c and this is yc bar plus 0. So that means finally what will get this x value, y bar c plus yc bar. yc bar. So that means what I can say, this is y XOR c now. That means y is equal to what, tell me now, A XOR B XOR with c. So this is nothing but what, tell me now, 1 2 4 7 min terms now. You tell me now which has a 1 2 4 7 min terms. Here this is a 4, this is 2, this is 1, this is 7. 1 2 4 7 is there, so first option. Right, all of you? Fine. Done. So here that's it for today's sessions. And next class, so all will continue the multiplexers and demultiplexer, decoders, encoders will continue. By the next topic, we'll finish the combination part. We can able to finish it. Okay. And tomorrow also we'll meet at tomorrow. Class is 2 p.m. 2 p.m. 2 to 5. Okay then. See you. Bye bye.